Hi, my name is Kristen and welcome to Science Looking Ahead for Second 9 Weeks, second grade. We begin on October 19th and end on December 18th. So here we go. Force, motion, and energy. The first thing we're going to be working with our students on is how forces cause change and energy exists in all sorts of different forms. The first thing we're going to do is we're going to trace the changes in the position of an object over time as the cup rolling on the floor or as a car like rolling down a ramp. So our students will be taking a cup on a basic piece of butcher paper, and as we push the cup, the students will trace the travel path of the cup, and they continue until it stops, and absolutely they can continue to push again and follow the travel path of the cup. And then we will do the exact same thing, and of course in our labeling we will say cup, and then we'll do the same thing with a car down a ramp, taking a marker, following the car, go all the way down, and then we will mark that car. And now the students are set up to be able to make a comparison statement about how the cup's motion differed or was similar to the car's motion. All right. So the next thing our students are going to do is they're going to compare how an object moves in terms of whether it's spinning, sliding, or rolling. And we're going to use common everyday objects. Lid from one of our LLI boxes was a great resource for putting paper on the inside for the students to work with. We have Matchbox cars. We have our Math Manipulative Geo 3D prisms. And we have our rocks. And what we're going to do is we're going to determine how these objects are going to roll or slide, or spin. So each student, if they're working in groups, can take an object, and then they can determine what that object is going to do. And they kind of trace the travel path. They can also see if an object might move in multiple ways. So I can roll, or I can also spin, in the case of a sphere. If I take my cone, he worked in a similar manner to the cup from rolling on the floor. Take our rectangular prism. He does more of a slide, stop, slide, stop, slide, stop. So the students now can once again make comparisons in terms of what is happening in terms of the movement. Was it sliding, was it rolling, or was it spinning? And then we can have a reflection component in our science journal as to what those motions look like and how they can determine and be used then in an everyday world atmosphere in the extent of, for example, the wheels on a car. What part of the car is rolling? And it would be then the wheels. So the next part of 2.6 is 2.6a, which the students are going to investigate using all sorts of different tools. A flashlight, a hot plate, in order to determine increasing and decreasing amounts of light, increasing and decreasing amounts of heat, and increasing and decreasing amounts of sound. In terms of ideas behind objects such as the color of an object appearing different due to the amounts of light, and also how butter might melt in terms of increasing or decreasing amounts of heat. And the final thing that we're going to do is 2.6b as in boy, which is identifying how magnets are used in everyday life. So we have, our tool is many different kinds of bar magnets. All right, so our students are going to use a bar magnet and they're going to search and dig for buried treasure. So they're going to take the bar magnet, and as you've buried items that are both magnetic and not magnetic, the students can actually guide the bar magnet over and attract objects that are magnetic, and now we can kind of have a different type of sorting just to remind our students exactly about what magnets do and how they work, attracting, repelling, those types of things. So then once they've got them sorted, then we can have some serious fun with how magnets are used in everyday life. And you can get little micro cars that have the magnet on the bottom, and the students can utilize items like sheets of paper, put the car on top of the paper, and then they can use the magnet to push and pull the car. We can even set it up in a maze and they can do car races through it. You can have all sorts of fun with your students with magnets and magnetic cars. And then finally, referencing magnets in the everyday world, have your students practice with the repelling feature of a magnet and watch the weightlessness occur between the magnets. They don't want to connect when the same poles are near each other. So ask your students, so how could I make something really massive like a bullet train? Or make something really, really massive like a huge pile of metal from a garbage metal recycling plant? How could I make a crane pick up something that's so heavy if at the bottom of it, it's so incredibly light? And have that conversation about how that works. Thanks for playing, and we'll see you in second grade science. Keep it hands-on and keep it engaging.